Hello everyone, welcome again to Integral Calculus, and for today's video, we would be solving for plane areas in polar coordinates. But first, before solving for plane areas, let's have a little bit of a recap first from your plane geometry. So polar coordinates, which is this one right here, are points labeled as r theta and are plotted on a polar grid. So suppose that these are to be your polar grids. So let's say that this one right here is to be your polar grid in terms of degrees or in sexagesimal units, so degrees. So from that, this is now to be your 0-degree mark, or the positive x-axis. This is to be your 90-degree mark. This is to be your 180 degrees. This is to be your 270 degrees. And this point right here is also to be your 360 degrees. So this mark right here is both your 0-degree and 360-degree mark. So let's say that this polar grid right here is in terms of radians. So this is once again radians. So from that, this is to be your 0 radian mark. This is to be your pi over 2 rad mark. This is to be your pi. This is to be your 3 pi over 2. So this one these ones right here are basically these ones right here converted into radians. So our conversion factor from degrees to radians is that 180 degrees is to be equal to 1 pi radians. So this is to be our conversion factor for this particular polar coordinates. So as you can see here, our points are labeled as r and theta, where r, this r right here, is to be the distance from the origin to the point that you are labeling, and this theta right here is to be your angle in reference to the positive x-axis counterclockwise. So suppose that in radians, so let's say that our point here is to be, let's say 5 pi over 2. So the distance from the point from the origin is to be 5, and its angle from the positive x-axis is to be pi over 2. So meaning it would be this one right here. So let's say that this one right here is to be 5. So this one right here is to be your point, since this distance right here is to be, once again, 5, and it has an angle of pi over 2 from your 0-degree mark. And let's say that we are to plot a certain polar coordinate in our sexagesimal polar grid or our degrees polar grid. So let's say our point is to be 4, and let's say 150 degrees. So meaning that is approximately in this point right here, approximately. So let's say there. So suppose that the length of this line right here is to be 4, and this angle right here is to be 150 degrees. It means that the point that we are referring to here is to be this point right here. So that's how you would be plotting your polar coordinates. So let's plot this function for an example. So in this problem right here, our angle is to be in terms of degrees. So we are to plot the function r is equal to sine theta in polar coordinates. So what you would be doing is that you would be substituting any value in this function right here for you to get the value for your r. So looking at the calculator to your left, so let's say our function is to be sine theta, and I would be assigning a variable x here. So sine alpha x, so there. And I would be pressing the button calc here. So calc and press 0. So what is the value of x? That is to be 0, meaning our sine x is equal to 0. Thus, when our angle is to be equal to 0, the value for your r is to be equal to 0. So once again, pressing calc. So your calculator would ask you what is to be the value for your x in your chosen function. And let's say I want it to be 30 degrees. So 3, 0, press enter. And as you can see, the value for your sine x is to be equal to 0.5. Thus, 0.5 here. So skipping at this point, let's say our angle is to be 120 degrees. So once again, in this function right here, sine x, pressing calc would make your calculator ask you what the value of x is. And let's say our value of x is to be equal to 120 degrees. Pressing enter here would give you an answer of 0.866. So these values right here are the answers of from this function right here once that you would be substituting these values right here. Okay, so if we are to plot this in a polar graph, so looking at this one right here, so let's say that this is to be your polar coordinate. So as you can see to your left, your value for r is equal to 0 when theta is equal to 0. So meaning, at this point right here, our value is to be 0. But what is the value of your r when theta is equal to 30 degrees? So meaning at this point right here, that is to be 0.5. So as you can see, this is now to be this point right here. So that is 0.5. So I would just be zooming in for you to see it clearly. So as you can see, that is to be 0.5 over here. So once again, the length from your origin up to this point is to be equal to 0.5. So there. And what is to be the value for your r when your angle is to be 45 degrees? That is approximately in this location right here, which is 0.707. So if we are to plot the whole function or the whole graph to your left, it would be this one right here. So from 0 degrees to 30 degrees to 60 degrees to 90 degrees to 120 degrees to 150 degrees up until 180 degrees, you would be plotting this one right here, which is basically a circle. So there, and if you want to solve for the area here, so as you can see, this is basically a circle. And the area for a circle is to be pi r squared, or let's say pi d squared over 4. So it would be as simple as that if you are to be given this function right here.